In this video, we'll talk about the Wheelhouse 2 rate of turn computation. Wheelhouse 2 computes rate of turn, displayed here on the screen, from the AIS heading input. If I press F5, here is a checkbox that allows me to disable the rate of turn. If I uncheck this and then press OK and then restart the program, then rate of turn will disappear from this data panel. This is a vessel that is just completing a sharp turn here, and the rate of turn is shown at negative 21 degrees per minute, and the vessel is starting to straighten up. And notice there's a pale red background to visually cue the pilot that this is the rate of turn field, because sometimes when values are similar between speed over ground and rate of turn, we don't want the pilot to mistake those two fields. So the visual cueing there. Now if it were turning to the starboard side, it would be a green background. Now the vessel is starting to straighten up here, so the rate of turn is declining. And close that vessel tag. If I press B for the night colors, the rate of turn has a red background there. It's a darker red, and so we'll watch the vessel a little bit here. While it's straightening up there, we'll talk a little bit about the characteristics of it. Now the question comes up, why does Raven not display the rate of turn coming from the AIS pilot plug? And the answer is that the field data indicates that the AIS transponder commonly provides a rate of turn value that indicates either 0, pegged, or invalid. So for whatever reason, the AIS pilot plug does not provide a reliable rate of turn. So we have to try to figure out how to compute it. And since we have a fairly coarse, whole degrees per minute of heading coming out of the AIS transponder, there's going to be certain restrictions we have on how accurate our rate of turn can be. Rate of turn now is down to negative 2.9, which simply means that it's turning to the port side. Finally, now we are straightening back up. We're coming back to the starboard side, 2 degrees per minute, rotating back to the starboard side. How does Raven get degrees per minute from AIS pilot plug? The answer: Raven's special algorithm estimates rate of turn in degrees and tenths of degree per minute from the timing of the changes in the AIS heading. However, the 1 degree resolution and the 1 second update interval of the AIS heading limit the responsiveness and accuracy that the Raven rate of turn can achieve. And so we have certain characteristics that this rate of turn computation has based on the restrictions of whole heading degrees once per second. And these characteristics are, one, the display lags somewhat when rate of turn increases or decreases. That is to say, the rate of change of rate of turn. And then also, 2, the accuracy of the computed rate of turn is within about 2 degrees per minute during a constant rate of turn. And then 3, accuracy and response are better at higher rates of turn. Now, one other thing we can say about the rate of turn is that if you press F for future predictions, here is future prediction dialog. It allows you to give the time in seconds between each future prediction and then the number of future predicted positions. So this is 60 seconds between positions and then 5 positions. So, and there they are computed out. You can see that there's a curve in that prediction projection there because the rate of turn is to the starboard side. So then the curve is to the starboard side. Now we're going to come down here with this vessel and we're going to turn it around. Might be interesting to watch it just for a little bit. In order to get down there, I'm actually replaying a raw AIS log file to get this screen up. I'm going to speed it up, which will get it down there pretty quick. It'll affect the rate of turn actually, but just want to get down there quickly so we can see how the thing acts. It'll settle down here in a minute. We're not going to watch the whole thing, but you get the idea. We'll just stay here long enough for the rate of turn to normalize back again. Notice it had pegged out there due to me speeding it up like that. And it's coming back down. This might be a chance to, if I press the night colors, to see what green looks like in the night colors. That light green might be a bit bright for night. We might need to change that to something less. We'll see how that works out. Anyway, so now the thing has settled down a bit, and oops, I need to close this guy here. This future prediction projection here can be useful in docking. So that's it, a little bit of short rundown on rate of turn. And like I said, don't forget that if you want to turn it off, you can uncheck that box and restart the program, and it's gone. Then you can, if you want to turn it back on, check the box. Unfortunately, you do have to restart the program each time you uncheck or check that box to change whether or not the rate of turn appears on the screen here. That is a little bit inconvenient, but the idea is that the pilot either wants it or he doesn't. Okay.